Let's take a look at some data of our R&D process. Let me explain the single board pressure drop. The single board pressure drop is injecting gas. To measure the pressure drop at different gas volumes, the double board pressure drop is under gas limit. The pressure drop at different flow rates. From this experimental data, we can see that the single board and wet board pressure drops with the gas flow, and gas flow rate has a positive linear relationship. This means that as the gas volume increases, our resistance increases. The increase in resistance will lead to an increase in pressure drop. This law is of great significance to the design and has important guiding significance. When designing we should fully consider the impact of gas volume changes on the pressure drop to ensure the system can operate stably and efficiently. Let's take a look at the fixed air volume, the relationship between absorption rate. It can be seen, the gas-liquid ratio and the absorption ratio, there is a negative correlation. As the gas-liquid ratio increases, the absorption rate can be seen that the gas-liquid ratio has a negative correlation with the absorption rate. As the gas-liquid ratio increases, the absorption rate, we focus on a 351 ratio, 352, and the absorption rate, 10% carbon dioxide content, the gas probe. Sorry, this is the absorption rate, and the change in gas volume, 350. Such a specific gas-liquid ratio represents a specific working condition, and 10% carbon dioxide content also has practical reference significance. When the gas volume changes, the contact between gas and liquid mass transfer process will be affected, which will affect the absorption rate. Generally, increase in gas may, because the residence time of gas in the microchannel and insufficient contact with the liquid, which will affect the absorption rate. On the contrary, if the gas and liquid have enough time to contact, the absorption rate may increase. But from our current data, as the gas volume increases, our absorption rate has increased slightly. The second is hydraulic flow absorption rate. We did not proceed further, so this data is not referential. This trend is because our reaction is determined by ship dynamics rather than volume. Let's compare it by referring to the experimental literature data. The reaction constant is below the millisecond. The reaction constant should be in the order of 10 to 5 mil. While our flow velocity has not reached such a high level, it is limited by this enterprise. Ship's flow rate increases. It will affect the transmission effect of the enterprise, thereby enhancing its enterprise mass transfer.
And thereby increase absorption.